In this video, I'm going to be covering the Beckmann rearrangement. So the Beckmann rearrangement is a rearrangement where we can take an oxime and turn it into an amide. So I guess first question would be, what is an oxime? So a general idea of an oxime would be any amine where the hydrogen is replaced with an alcohol. Or I guess in this case, we would really just call it an OH group. So how do we turn this into an amide? Well, they do that with acid. So if you put in sulfuric acid, so H2SO4 or just H+, the first thing that's going to happen is you're going to protonate that alcohol. Or again, it's just an OH group in this case. So protonating that OH group makes it become a better leaving group. And so we have reason to let it kick off. So this is what we'd have with that hydrogen stuck on there. And then the way we're going to kick it off is by doing what's kind of like a carbo-cation rearrangement, but a little bit different style. It's so similar to the Baeyer-Villiger, where we're going to let a single bond break through a carbon. And in this case, it'll attach to this nitrogen. And when it attaches to that nitrogen, it's going to have to kick out water. So we now have something that looked, in this case, like a 7-member ring with nitrogen as one of the atoms there. So I'm going to put nitrogen at the top. It's still got that double bond on it. And you'd have something like that. We did kick out, or we did lose one bond to this atom right down here. So that atom would be this atom. Since we lost that bond, we should give it a positive charge. Okay, so at this point, if we suggested some water came along, so here's some H2O. We see H2O, it would be attracted to the positive charge, and its electrons would be given up to that carbon. When you do that, you get what would look like this stuff down here. And there's your oxygen with, you can say, one proton hanging out, positively charged. Now we should just satisfy the charge on that oxygen. So we could either suggest another water molecule comes, or we could suggest the conjugate base of if we use sulfuric acid, we use conjugate base of sulfuric acid, or whatever it was that was floating around. So I'm going to just write a capital B with some electrons next to it. I'm going to let that act as my base here, giving those electrons back to the oxygen. So again, what we have now is still that 7-member ring. Looks just like that. We can recognize that, that this group right here is just like an enol to us. So we're going to treat it just like it was an enol. And we know that we are in an acidic environment because we have some sulfuric acid floating around. So if we're in an acidic environment, let's just perform a tautomerization. And then we can see we can get up to our final product, which would be, so tautomerization, do that in green, which would be our final amide. So need that H there, just like that. So we have a 7-member ring, and in that ring we have an amide.